All right, guys, so now we're going to talk about covalent bonding. So we talked about ionic bonding, and that's where an electron jumps from one molecule to another, one or more electrons, and now the positive and negative charges are attracted to each other. So covalent bonds is a little bit different. And so a molecule that has covalent bonding in it is oxygen gas, O2. And so I've done the math here to determine how many neutrons are present, how many electrons are present, and we know there's 8 protons because it's oxygen. So I'm going to go ahead and draw the Bohr model for this guy. So we have 8 protons, 8 neutrons, and we also have 8 electrons. So there's going to be 2 on the first shell, and there's going to be 6, 1, 2, 3, 4, 5, 6 on the second shell. And this is O2, so there's 2 atoms of oxygen. So 8 protons, 8 neutrons. We got 2 electrons there, and then 6, 2, 3, 4, 5, 6 around the outside. Okay, so remember we talked about before that atoms like to have a full outer shell. But atoms aren't just going to be like, oh, here, you take the electrons, you be a happy atom, and I'm not going to. They're only going to interact if it's also going to do something for them. Okay, so when we look at these oxygens, we see that each of them has 6 electrons in their outer shell. Their outer shell is the second shell. So they both each need to get rid of 6 or to get 2 more to be happy, okay? So it's not like this guy is just gonna give this other guy 2 electrons and like, you be happy and I'll just be over here sad. That's not how it works. Since both of them need electrons, what they decide to do is they share electrons. Okay, so to be able to do a covalent bond, you have to need an electron, but you also have to have one that you can share, because this guy's not going to share with him if he doesn't share back with him. Okay, so what they do is they actually end up sharing these electrons. So if they share these 2, now this guy on his outer shell has 1, 2, 3, 4, 5, 6, 7. He can count that other one. Because remember, those electrons are zipping around in that 3-dimensional space. So this electron zips around here, but then he can zip around over here as well. So he zips around this one and zips around this one. Well, now they each only have 7. So they're still not happy. So they actually share 2 sets of electrons. And that's a double covalent bond. And you can see it in the textbook. Sometimes it'll be drawn like this. Sometimes we have the ball and stick model, or sometimes it looks like this with a double bond there. So that is oxygen. So this can happen. It could be up to a triple bond, and single, double, or triple bond. So a single would be sharing 1 set of electrons, double 2 sets, triples 3 sets of electrons. And it doesn't have to be between the same atoms. For example, CH4. CH4 is 1 carbon and 4 hydrogen atoms. Now all those hydrogen atoms, they only have 1 electron each. So they each need 1 more to make their shell full. And carbon, it needs 4 more to make its shell full. So it shares 1 with each of the hydrogens. And so we'll go into different properties with covalent bonds later, but this is different than an ionic bond, right? This is an actual, they're sharing the electron. This bond is stronger than the ionic bond because it is not just an electrostatic interaction between these guys. They are actually sharing that electron. So what's happening, the electron that was originally from this guy over here is zipping around this way and around this guy. So he's shared between both of them. All right, that's covalent bonds, guys.